Hello everyone. Welcome to my lecture series of data structures and algorithm. I hope you have gone through the previous lecture on the introduction of linear queue. So in today's lecture, we will study about insertion in linear queue. So more technically, insertion in linear queue is also called as Enqueue, right? Now, before understanding the example and algorithm of insertion in linear queue, we should understand some of the points which are very important. So first case is when queue is full and we further try to insert an element into the queue, that condition will lead to overflow condition. So what is overflow condition? Already the queue is full. So there is no place to enter any other element. So it will simply throw an error message that you cannot insert any other element into the queue. Case 2 is when queue is empty. In that case, both your rear pointer and front pointer will point to -1. There is the case 3 when queue is full. So in that case, your rear will be pointing to size -1. So now let's understand insertion in linear queue, or you can say Enqueue in linear queue with the help of example. So initially we can see that here the size of the queue is, number of elements in the queue are 4, and the first index is 0 and last index is size -1, that is 4 minus 1 is equal to 3, right? So all the cells are empty. It means there are no elements in the linear queue, and so it is empty. So front and rear pointer both are pointing to -1. As soon as I enter the first element into the linear queue, I have inserted the element. So before that, front and rear will point to 0 location, and then when the location has been updated, then the data will be inserted. Again, when we are going to insert any element at the next location, first the rear pointer will be incremented by 1, and then we will be inserting the data. Now you can see that first your rear pointer will be incremented, then the data will be added, right? Now you can see first rear was incremented, then the data or element was inserted. Again, you want to insert one more element, then first rear will be incremented and then data is being inserted. Again, you want to insert any one more element, then first rear will be incremented and then data or element is being added, right? So this was about insertion in the linear queue. And when the rear is pointing to last location, that is size -1, so it means the linear queue is full. And in that case, if you are again trying to insert any element into the linear queue, that will give to the condition of overflow. When the queue is full and you are trying to insert new element into the queue, then that condition is called as overflow, right? Now let's understand the algorithm of insertion or Enqueue in linear queue, right? So algorithm for insertion in linear queue. Queue is a variable which is pointing to the array, front for deletion, rear pointer for insertion, and data is the element that you want to enter into the linear queue. So the name of the algorithm is insert underscore queue. Queue is the array, front pointer for deletion, rear pointer for insertion, and data that you want to enter. So in step 1, we have to initially check whether the queue is empty or it is full. So if it is full, there is no point of inserting anything into it. So if rear is pointing to size -1, then we will simply print a message that overflow and we will come out of it. It means that there is no space to insert data in the queue, right? Step 2 is first condition was in if, next condition will be in else if. So if this condition is not true, then we'll come to the next condition. In this condition, we will check if rear is equal to -1. In that case, we know that the queue is empty. So then first the rear pointer and the front pointer will be set to 0. And then at the new location, that is queue of 0, I will be inserting the data. So the first value inserted in the queue is at 0th location, right? Now coming to the third case. In the third case, that will come in else condition. This is the case when there are already some elements available in the queue. So let's say It can be any position. So earlier the position was rear and it was pointing to, let's say, third index. So now if we want to insert at any element at the fourth index, then in that case rear will be first incremented. So it will be 3 plus 1, and the new rear will be 4. So Q fourth location, that is of new location, the data will be inserted. So value inserted in the queue at rear position, which is not the first index, right? So after inserting an element into the queue, we'll simply exit from the given algorithm. And in this way, this was all about the algorithm of linear queue, insertion in linear queue, right? Now coming to time complexity for enqueue or insertion operation in linear queue, that is big O of 1. Because to just insert one single element at the given index, it just takes constant time, right? So this was all about the basics of insertion in linear queue. If you have any query, please post your queries in the comment box. In the next lecture, we will study about deletion in linear queue. Till then, stay tuned to my channel and wait for my next video. Thank you so much.